the models are really lazy. Here's my favorite Claude Code one at the moment. Due to context window limitations, I'm stopping right now. You're like, dude, come on, try harder. Do you know what I mean?
We were right in the middle of it.
Imagine a junior engineer just went, no, it's 4:30 in the afternoon. I'm going to knock off in 30 minutes. So there's no point me looking at this. I'm going home now.
All that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE brings together a panel of the smartest minds in technology to distill down what's important in the crazy world of artificial intelligence. Joining us today are three incredible panelists. We've got Chris Hay, Distinguished Engineer, Olivia Buzek, Lead Developer Advocate for AI, and Gabe Goodhart, Chief Architect, AI Open Innovation. This is going to be a fun episode. It's one of our end-of-year episodes, so we are basically departing from our usual news story format. And I wanted to get this group together specifically to talk about the past, present, and future of code generation. I think, in my opinion, code generation is basically one of the biggest stories of the year for AI, right? Starting from January to now, like the work of engineering has changed in a very significant way. And, from Cursor and Windsurf to Claude Code and sort of the rise of vibe coding as a thing, really, if you're like, where's the most salient impact of AI happening right now? It's kind of in software engineering and code generation. And so I guess, Olivia, maybe I'll start with you. I think the question is like, what do you think comes next, right? Are we like now entering a mature space, or is next year going to be kind of like as crazy and tumultuous as 2025 was, in your opinion?
I think it's a little bit of both. So what I've seen over the last year is that even the AI skeptics are starting to use AI in their work almost every day. So when you're starting a project, you definitely use AI to get your things off the ground. We have the evolution of things like the agents.md files that people are putting in their projects so that you have a standard way that your particular project will be interpreted by the AI. And, in hiring processes, we're seeing people actually checking to see whether or not you understand how to know or how to use the AI tools. So all of that points in a strong direction of this thing is here, it's here to stay. At the same time, I think we see a lot of limitations as well. So far, I have yet to hear anybody say, oh yeah, this is as capable as a human. I hand off all sorts of tasks to it. I literally just tell it to look at my board and take off the next task and take care of things for me, because it's just not there yet, and it's just not that trustworthy yet. And we have seen a few catastrophic failures over the course of the year.
Right. Yeah. And I did want to get into that as kind of like, it's almost a little bit barbell shaped in my mind, right? I think, Gabe, one of the things I wanted to talk to you about was, I'm not a day in, day out coder. I used to be, but I'm terrible at coding. So I stopped doing it and moved to a different profession, podcast host. And I guess the question for you is at least for me, these tools have kind of revolutionized the game because I can just sit down and start having fun. But I guess the question, to Olivia's point, is do we still feel like there's kind of a gap to using this at the frontier, the most complex, the hardest software applications? I guess the question is whether or not this is still more in the realm of if you're doing day in, day out coding work, or you're kind of a junior engineer, that's where most of the action is happening. Do you buy that as a premise?
I would have said yes last week.
What changed?
I used Claude 4.5 Opus to crack a problem that I have been trying to crack for months, and it nailed it in under an hour. And this is a problem that is deep in the guts of Llama CPP, trying to get better performance out of the recurrent models, optimizing the metal kernels, understanding the shape of, grid layouts and thread group dynamics and SIMD group memory sharing, and just the gnarliest corners of Gorpy bits. And let me just be clear, the official internet documentation for Apple Metal programming is a 2,000-page PDF. That's it. There is no, you go to CUDA and the internet is full of good information. I expect AI models to nail CUDA. But for Metal, I was blown away at how strong it was. So to that end, I will say, I think the barbell-shaped analogy or something shaped that is not nice and uniform, whatever physical shape you choose, is exactly my experience right now. These models can do some amazing stuff, and they can fall really, really, really flat in what should be really simple use cases. So the opposite end of the spectrum, the reason I would have said this a week ago, was I also heavily used Claude Code to try to build out a CLI for a pretty straightforward REST API. And it did a fantastic job of cranking out a beautiful CLI with lots of nice, pretty colors and inline JSON highlighting and all sorts of awesome stuff that was 100% code coverage too. Like the tests were great. They all just mocked everything and didn't actually test anything and nothing worked. But it was so cool. And then I spent a week having to, somebody I think from the Continue team coined this phrase of chiseling. So you basically like use it to create the rough block, and then you have to chisel out the shape of what you actually want your statue to look like underneath the very rough block that you just like splatted out with a code assistant. So this was my experience. It actually probably took much longer. Now the end product might be prettier. I probably wouldn't have come up with all the latest, coolest CLI libraries myself, but the process of actually like fixing all of the stuff that it just mocked away in the unit tests and said, sure, if I pretend that this is the right answer, then I got the right answer when I did this in my code, was really frustrating. So it's in some ways, I would have expected exactly the opposite experience, that generating a CLI against a well-defined REST API is bread and butter. Like that should just be for point and shoot, forget about it. And then, deep in the gnarly weeds of metal optimization is where it would fall over and have no idea what to do. But it's
actually like the reverse. Yeah, I think it's kind of like,
right.
Yeah, you're pointing out it's like the intuitions are flipped, right? You're like, how could you not get this right?
For me personally, what it points to is that I just don't quite have a good intuition about what it's going to be good at and what it's not going to be good at. And I've tried to build that intuition, which means that there's still some misalignment between the capabilities of these tools and sort of the day-to-day sort of mental model that at least I as a developer have around the complexity of a task and the difficulty of a task. So
yeah, that's right.
Still some learning on my part to do.
Well, and I do want to go to that point, right? Because I think, Chris, typically when we've seen these like high-profile failures, I think people are like, ha, look at the terrible AI. And I'm kind of the view is just like maybe those kind of get ironed out over time as engineers understand like what these systems are good and bad at. So it's less of a technical problem and actually more of like a engineering culture and norms and understanding problem. Like we've got this hammer, but we're still not really sure what hammers are good for yet. And so we're kind of swinging it around being like, oh, it wasn't really good for that. And like maybe those problems kind of like disappear with time as we kind of get a little bit more mature on how to use these applications. Do you buy that?
Yeah, I think so. I think one of the questions I like to ask myself with the coding models is, who is the architect? And I asked that question for a second because if the coding assistant is the architect, then it's going to choose the framework, it's going to choose which libraries, it's going to choose whether it's going to mock or not mock, etc. Right? You're putting all of the decisions onto the model. And that is okay. I mean, if you don't really know a language or you don't know the frameworks or you're not a UI person or whatever, then you don't really have much of a choice, right? So you're saying, actually, I don't quite know what I'm doing here, so I'm more in the vibing world. So go do that. And I think, therefore, it can make bad decisions in that sense. And Gabe, to your point, the models are really lazy, right? If they think they can get away with just mocking something up, or they can just go, I can't, here's my favorite Claude Code one at the moment. Due to context window limitations, I'm stopping right now. You're like, dude, come on, try harder. Do you know what I mean?
We were right in the middle of it.
Imagine a junior engineer just went, no, it's 4:30 in the afternoon. I'm going to knock off in 30 minutes. So there's no point me looking at this. I'm going home now. You'd be like, you're fired, But so I think there's a fair point. But asking who is the architect in this case. And then sometimes it's okay not to be the architect, right? You're vibing, you're prototyping, you're doing whatever. But I think you're in a different paradigm when you want to start productionizing. And that's where you have to really use things like the rules. You have to use, like if you're in Claude Code, your Claude MD or your Agents MD. If you're in Cursor, you need to use rules or client or whatever to really guide the model and say, this is the architecture that I expect. These are the standards that I want you to follow. And therefore, you probably have to put as much effort into architecting as you would normally do with architecture. So I think that is the big paradigm shift that is probably happening, which is architecture is going to become more important, but actually being able to write your architecture, which is AI friendly, agent friendly, as opposed to in a Word document or a UML diagram sitting somewhere on the cloud, right? It is really about orchestrating with the AI, and then you're going to get really fast feedback loops.
Well, and I think that's actually one of the things I do want to talk a little bit more about. This kind of like the evolving role of like the engineer or the programmer in all this. And, I think one of the things I'm really interested in is how all these models are kind of differentiating with time, right? Like we live in a world, I think, Gabe, you might have made this comment in a previous episode. You were like, we live in like model abundance. There's like all these models and they're all really, really good. I guess I'm kind of interested in like, if you're seeing differentiation, and Olivia, maybe I'll toss this question back to you, is, just take OpenAI and Anthropic for a second. Like, do you feel like these models are approaching code gen differently? Like, is the kind of code they're producing in flavor different, or is everybody kind of converging on the same kind of code generation with time? And I ask that a little bit because it's kind of like you could imagine being like, oh, I really understand what OpenAI is good and bad at, but I have no idea what Anthropic's good and bad at. And that really has big implications for how almost these models become a kind of like programming language with time, right? Like that, it's almost like a tribe that you say like, oh, I'm a Pythonista. I'm wondering if that kind of thing is on its way, or if you're not seeing that.
Currently, I'm seeing a lot of people just in an experimental phase with a whole bunch of different ones because I don't know that we have solved that characterization. That characterization may evolve more over time. I also think it's in some ways less about the models themselves and more about the agent architecture that's underlying those code assistants. And I think that is making a much larger difference. So, for example, when I'm playing with when I'm just playing with the model itself on something like Continue in my IDE, then I'm not getting that agent experience. And so because it doesn't have very many agents to it, like it almost doesn't matter what model I throw at a particular problem, it can only do so much. Where you see a huge difference, though, is in the actual planning for a task. So like in one assistant, it'll be like, oh, my planning tends to be focused more around like security and optimization problems. And so it'll get stuck on that part. And another agent will be more interested in like, I really want to do this mocking thing that Gabe is talking about. And so you'll see like tendencies because of the agent architecture that's underlying it, which is of course completely opaque to the user other than the way that you start feeling it out.
Yeah, that's actually really interesting. You're almost saying that this is like less of a function of the model, but just kind of agent orchestration is producing these like differentiations of time.
Right.
Gabe, I guess you're nodding, shaking your head if you want to jump in.
Yeah, I'm doing this weird nod, shake head thing at the same time because, Olivia, when you said that, that's exactly the comment I wanted to make here as well, is that I've said this on many episodes, but the user experience of any one of these AI tools is a combination of the quality of the model and the quality of the system that is built around the model. And in this case, I have seen tools, literally multiple different tools using the Claude family of models behave extremely differently with exactly the same flavor of problem thrown at them. And it comes down to the implementation of simple things like context compaction. What do you do when you get a 20,000 line C++ file thrown at you? Do you just explode, or do you carefully read it in chunks of 100 lines and keep going? What do you do when you are unable to find an answer on the internet, or when you try an experiment and it fails? How do you back up and try again? So these things are all at that orchestration layer. And I think this is where the actual individual tools are going to differentiate themselves. That's why I keep coming back to Claude Code, because I think of all of the tools I've tried, they have this experience of it just works, nailed. Everything else has just required so much more finagling from me and sort of babysitting from me. Whereas with Claude Code, I don't have to select what mode it's in. I don't have to, carefully choose, I've got to only send you files that have context that I know you can handle. I don't have to do any of that stuff. I just point it at files on the internet. I point it at files on my local machine. It asks me at the right times when to do what operations, and it goes to town. So that's my personal favorite these days. And I really think this, this is the tooling layer is really important. That said, the reason I was doing the funky shake the head thing is that, again, using this example from the last couple of days, I did this work on the metal optimization with Claude Code 4.5 Opus and was blown away. Literally in parallel.
When you said you did it, Gabe, I mean, you just said you.
All right,
you said you knew nothing about it, and it was gnarly stuff. And Claude Opus figured it for you. How much did you actually do?
Okay, all right. We'll unpack that one. So actually, yes. This was actually to your comment, Chris. I love your framing of who's the architect here, right? So I have been banging my head against this problem for months now. I've been trying to tackle this from the mathematical perspective of reformulating the SSM scan operation as SSD, following the Mamba 2 paper, blah 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 blah. And it turns out I was looking in the wrong place. The right place to look was the very inefficient SSM conv implementation that didn't take advantage of thread grouping. Who knew? So I actually was the one that figured that out myself by carefully commenting out chunks of code and realizing that if I took away the SSM conv operation, I got double the performance, which was the light bulb for me that said, shoot, I've been looking in the wrong place. Then I went over to, and I've read this kernel many times myself. I have not seen anything that says this is clearly a problem because I don't know the ins and outs of how the metal GPU is architected. So I got all the way to the point of I found the problem, but I don't know what to do with it. I pointed Claude at that and said, Claude, here's what I'm experiencing. Here are literally the commands I've been running to isolate this. Here's the line I had to comment out to get to this point of discovery. Please take it from here. And it was able to say, I read that code. Thank you for the pointers. The problem is right there, this line. And that was where we got to. So I did a lot of the work to get there. Claude did the work to actually solve the problem.
And actually, Gabe, I think to your point, I think you're sort of really stating where we are just now, which is if you don't know what you're doing at all, you will get so far. It won't be the most maintainable code. It will be a bit muddy, whatever, etc. But today, you still need the human part of that loop, right? You need to guide Claude. And actually, to your point in Claude Code, it really does deal in a couple of hundred lines at a time. So it's a kind of very, very narrow window. And yeah, you can direct and push it to different places. So if you need that broader view and you need it to look at the larger context, you're either having to do some thinking yourself or you're going to the Claude web interface and you're typing in there going, you think a little bit further for me. But the point is, you do need to do that thinking today. I am not so sure that is going to be so necessary in the future, if I'm honest.
What I was going to ask is
this.
is the 100-line thing, that's a design choice by Anthropic, right?
Yeah.
So I guess how do we read that, right? The most generous interpretation is they actually want you to do some thinking. But I don't know if you would read it that way,
I
Chris.
think they just don't want you to burn your context windows. You know what I mean? I really think it's as simple as that. But it is actually remarkably efficient at it, right? I mean, if you look at the tools that Claude Code has, it actually has very little tools, right? It's got fetch, it's got grep, it's got bash.
What more do you need? What more do you need?
I'm gonna be honest, that's actually good enough.
Maybe?
So yeah, exactly.
Said.
Well, you get them via bash, Gabe. So
that's true. Yes.
So in reality, it actually has very little tools, but it is incredible in the way that it's able to execute. So I sometimes question my lifestyle choices in building MCP servers every so often, going, am I wasting my time here because Claude Code does so well with so little tools? But I just think that it reflects kind of where we are today, though. But I do believe in the future that the tools are going to get more efficient. They're not only going to be using grep. They're, if you look at things like Cursor, for example, they are indexing your code base. I'm sure Claude Code is on that path already. In fact, I think they released something recently, and therefore, I think a lot of those constraints we're talking about are going to go away. Ultimately, I do think, though, that you are still going to be part of that loop. You still want to be that architect. But I think the progression is actually, I think it's just treat it like another compiler. I hate to say it this way, but we went from punch cards to assembly to C to C++ to Java, and then we're at Pythons to JavaScripts to TypeScripts, etc. So you've went up and up and up the stack. But apart from Gabe and his story about looking at Apple Metal there, but do we really go and look at the assembly code that often now? No, because we kind of trust the tools to do that job. And I just wonder, in fact, I don't wonder, I'm pretty sure we're in that kind of paradigm shift. And but you still need to know what's going on below the hood, right? But I think we're at another higher level abstraction going forward.
Well, yeah, and to wrap up that, where we are today point, what I was going to say is, in parallel to doing this with 4.5 Opus, I did a simpler task with 4.5 Sonnet, and it needed way more oversight than what I had to give Opus. Opus actually did a great job of looking at Git history, looking at adjacent files, looking at all the pointers I gave it both on the web and locally, and needed ultimately very little oversight in solving a complex problem. Sonnet, on the other hand, I pointed it at a gnarly problem that's very hard to test because it crashed my terminal every time it was triggered. But literally the whole terminal app just died, which was a pain. But Sonnet claimed success like 3 or 4 times, and I had to keep going back and saying, no, I'm pretty sure that's not right. I'm pretty sure that's not right. So there is a model capability here, and I think the difference we're going to see, and I think I haven't tried this against Gemini 3 or the latest versions of the OpenAI 5 Codex models, or any of the other latest gen ones, but I suspect that that's the capability difference we're going to see, is essentially how much oversight do you have to give this sort of deep T expert that you're pointing at a specific problem. The thing that I think is going to be really interesting for next year is to see if that individual task-oriented deep T expert, when I say deep T, I'm referring to like the T-shaped skill sets, right? Like I think what we're seeing right now is that if you give one of these models a well-researched problem in a domain that you are not yourself a deep T expert that you could go do in great depth, it can actually do a very, very good job of solving that. But the more capable the model, the less you have to supervise that solution. I think going forward, we're going to see this paradigm that we see peeking out from under the covers with Google's anti-gravity of, I've hit a point where I can actually reliably trust that deep T expert is going to get the problem correct. So now I can start launching a bunch of these in parallel and not babysit them. I think that's the holy grail to get to next year. We're definitely not there yet. From what I hear from anti-gravity users, from other attempts at fleets of agents and becoming an agent manager, I don't think we're there yet. But I just smell test based on the capability gap from 4.5 Sonnet to 4.5 Opus. I'm curious if we will actually, I feel at least some optimism that we will get to that point next year where you can actually queue up large quantities of tasks with independent operation on them and basically only supervise them when they come back and tell you they're completed.
I'm going to move us on to a final topic, particularly, I think, fitting given the folks on this panel. But I do want to just take the last few minutes of this episode to talk about open source. So one of the big kind of narratives, I think meta-narratives in 2025 is like open source is like continuing to catch up, right? It used to be like, oh, give it a few months and then, open source will have what the state of the art had, in a few months. And then now it feels like basically where we've gotten is like, it's now kind of at parity or even like getting ahead of the proprietary models. And I guess, Olivia, just to kind of hear from you on your experience with this, like, I guess the question I have is like whether or not we're going to see that pattern also happen in the code gen space, where you see these open models start to be able to do code generation at like I don't know, like kind of a Claude level. Is that in the offing? Why or why not?
Yeah, so I think we have to make a little bit of a distinction here between at open weights and open source frameworks that are being used to do code gen. So I mentioned Continue, which is an open source framework that you can use for code gen stuff. As I mentioned, though, they haven't really leaned into agentic pieces yet. And so you're kind of on your own in terms of making that model highly, highly performant. But then a lot of these models that we're talking about are in fact open weights models where you can in fact download the weights and put them behind a whole bunch of different things. What we're not seeing yet, I think, is an openness within the most common tools to just use any open weights model on the open market, right? So we're not seeing every single code generation tool saying, well, you can just pop in whatever open weights model you want. They end up doing this hybrid synthesis thing of an open weights model combined with an agent architecture that is designed for that particular model, basically. And so I think we're still seeing a lot of combinations being more successful than the open weights models themselves. But that doesn't mean that the open weights models aren't powerful. It just means that they need a lot more guidance than being able to be used just off the shelf.
The one delta I would say on that is that Continue actually has leaned in heavily to agents, but Continue is, like many open source tooling layers, trying to split the difference between running against local models and against hosted closed models. So their agents work great if you plug in Claude or Gemini. And I spent a bunch of time last week trying to get it to work with Granite 4 Small, and it does not work very well. There are others out there like Open Code, which I also tried extensively with Granite 4 Small, to similar effect. Now, part of this could be simply the nature of the size of these models. I haven't tried running it against a really large sort of frontier level open model because I can't run that on my dev box. But I also think there is an inherent advantage of closed ecosystems to be able to co-evolve the model and the tooling together so that you're not trying to keep this sort of level of separation between the model's capabilities and the actual agentic patterns around it. I mean, all of these agentic pattern tooling layers for coding or otherwise involve a great deal of prompt engineering and a great deal of sort of manual tuning of, I've seen that it tends to fail in this corner case, so either I need to code my way or prompt my way out of that corner case and that sort of thing. And it's just really hard to do that in a model agnostic way. So I think that's one of the big advantages. I haven't personally tried like Qwen's direct Qwen 2.5 coder, like local CLI. I probably should give that one a shot because I think that's an example of an open ecosystem trying to do this where they have a model-specific open tooling layer. The one I have tried is pointing OpenAI's codex at GPT OSS 120B. And I would say that is a solid step up from running Continue or Open Code against Granite 4 Small. Again, model size is a big element here, but also the pairing of the model capabilities with the agent side. So I don't have a clear, decisive answer here, but I do think you're spot on to point out that this really has to do with the software layer and that's probably where there's the most catch up to be done on the open side relative to the model capabilities. But I think it's still, because of sort of the loose coupling in open source, I think we're going to see it a little bit harder to get to those peak performance capabilities.
Yeah, Olivia, this almost feels like it's a story of like vertical integration a little bit, where it's almost like maybe there's a structural advantage. The dream of open source is like you take a bunch of components off the shelf and we kind of click them together and like with a little bit of spit and polish, it works. But it feels like here the amount of work that still needs to get into it to get sort of like the model and the software all to work together is still something where like almost structurally open source kind of has like a problem doing. It's strong at other things, but in this particular case, it might feel like it has some limitations. does that mean we should be a little bit pessimistic about kind of like sort of, kind of fully open ecosystems for code gen? Or do you feel like there are things the community will do to kind of like, deal with this?
So I'm still heavily optimistic about it. I just don't think that we can draw the conclusion that open source is ever an off the shelf solution. So you're always, and I think this is true in every space, like if I, looked at like an Ubuntu GUI, I can do anything, but I have to know what I'm doing, right? Like I have to, even to this day, like if I'm using Linux for something, like it's going to require more configuration, but I can configure the heck out of it and I can get exactly what I want from it. So I think we'll see more of that. So I think if you can imagine a world where you end up having a lot more control over that agent architecture, and you get to choose also your open weights model as well, then you can basically say, well, I do these particular types of tasks. Like this is, 90% of my work looks like this. And turns out like Claude Code or it doesn't necessarily get me there, or Codex doesn't necessarily get me there, but I'm doing this particular type of task all the time. I'm not going to speculate about exactly which task that would be required for, but I would just believe that that's going to exist. And, these open ecosystem things are going to enable that to happen. And I also think that the development of this open ecosystem is allowing rapid innovation sharing and being able to make sure that we're always working at the state of the art, which is not something that you get when everybody is like fully closed. So in a world where everybody is completely closed, we can never make those comparisons of, is this model actually making the difference, or is this agent architecture making the difference? Once it's that tightly held together, then you end up in a world where you're only able to look at whether or not the two together are succeeding. You can never say, okay, I'm just going to change out the open weights model underneath. I'm going to change Opus to Sonnet or even, and then I'm going to check out GPT OSS. Like if you're completely unable to make those comparisons, you'll never know, is this caused by my agent architecture or is this caused by my model?
Oh, cool. And I think the thing I would say is the biggest problem in my mind is the cost of inference. And if we really analyze this for a second, the folks that are using Claude Code, we're all sitting there on our various plans. I sit in my Max Pro Plus whatever plan I'm on, right? And therefore, I'm never worrying about the cost of tokens. I would not be paying the API cost in a million years, right? And so therefore, I'm using Claude Code, and the only way I can use my Max plan is through Claude Code. I can't use an open source tool to go and connect to that. That's not allowed. And they're not the only ones that do that. Gemini is the same. Codex is the same. Even Quen and Kimi K2, they all offer similar plans there. But you're doing a subscription plan and you can only go through those tools. So you are locked into that tool there. Now you can go and talk to the other models, but you're going to be paying the API costs, and that is the problematic element. So whether you're a Cursor or Windsurf, etc., that's why they're all developing their own models, because they need something that can satisfy the subscription plan, because people don't want to pay per use, they want to pay per subscription. So when is this in reality going to change? The models need to be much, much smaller. So if you have a coding model that is 3 billion parameters, right? 7 billion parameters at a max or whatever, can run on your machine and is as capable as Opus 4.5 as it is today, then
there we go. Yeah.
At that point, all of the open source tools can go wild at that point. But until then, the cost of tokens, I think you're in that vertical stack, and it's hard to mix and match. Technically, you can do it, but economically, it just doesn't make a lot of sense. Now, Gabe, to cover your kind of points about the capability of the models, the good news, I have played with a bunch of those models. I'm like a model connoisseur. I love playing with different models, and I genuinely, when I did my Kimi K2 video, I was genuinely surprised at how good that model was. I was like, whoa, I mean, it's not a Claude 4.5 Sona or Opus levels, but it was pretty darn good. It was pretty darn good. And I would say the same. I was playing with the DeepSeek V3.2, the Reasoner model at the weekend, and again, incredible model. But do you know what? Open weight model, can I run it on my machine? No, I am, it's like I can download it, sure, after a few days, but I've got nothing I can run it on. Do you know what I mean? So I think inference needs to be sorted out. And until then, we're going to be sitting on these vertical stacks.
Yeah, absolutely.
100% agree.
Yeah, same.
Well, on that note of unanimity,
Mic drop.
Gabe, Olivia, Chris, this panel's fire. I wish I could bring it together once a quarter. It's amazing to have you all on the show. And that's all the time that we have for today. So thank you to all your listeners. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we'll see you next week on Mixture of Experts.